Hello friends, my name is Chouhan and welcome to my YouTube channel. In this Mathematics for Machine Learning series, today we'll be discussing L1 norm. L1 norm is also known as Manhattan distance, and it is a type of distance, or you can say a type of norm, and it's also used. We have Euclidean distance already discussed, right? So after Euclidean distance, Manhattan distance is the second option that people go for. So let's look into the formulas. Now let's look into L1 norm or Manhattan distance. So L1 norm is also known as Manhattan distance. So we have seen the Euclidean distance, right? So basically the Euclidean distance gives the shortest distance, but the Manhattan distance doesn't give you the shortest distance. So this is our point A, this is our point B. A is at 1, 2 and B is at 4, 5. And this is the Euclidean distance. This length is the Euclidean distance. Okay, this is our Euclidean distance. But the Manhattan distance is going to be this component plus this component. So this is M1 plus M2. This whole thing is going to be Manhattan distance. So it doesn't give you the shortest distance. It gives you this distance, which is like going in each component direction. So this is how we are. So this is like we're going in direction X, right? This is the X component and two times M2 unit, and we are going in Y component direction, M1 unit. So this is how we'll get the Manhattan distance. And this is basically the Manhattan distance. So Euclidean distance is the shortest distance. Manhattan distance is not the shortest distance. This is something like log. So the representation of the L1 norm is similar to the L2 norm, right? We have this vector AB. We have these two vertical lines, and in the subscript, we'll use 1 instead of 2. This represents the L1 norm. Okay, this is the L1 norm. And the L1 norm of vector AB is equals to Manhattan distance between point A and point B. Okay, so we have seen the norm is similar to distance, right? So that's the L1 norm is same as Manhattan distance between 2 points. So the formula for L1 norm is like this. This is the L1 norm. Basically, we take summation of absolute value of each component. Okay, take the absolute value. Um, this is like this is our component, right? W1, W2. We'll have for AB, we'll have two components, W1 and W2, and we are looping. We are summing over each of the component. We are taking the absolute value. So this will give us the Manhattan distance. So for this vector AB, which is 3, 3, we'll have absolute value of 3 plus absolute value of 3, it is 9. So the Manhattan distance here is 9. Absolute value is like if you have minus 3, you take the absolute value, you get 3, right? If you have plus 3, then if you take the absolute value, you get 3. So basically, it converts the negative number into positive number with the same value. So that's how we calculate the Manhattan distance, or sorry, the Aron norm. And let's look into the Manhattan distance formula. So we need to calculate the distance between 2 points, right? So the Manhattan distance between point A and point B is given like using this formula. Summation over I equals to 1 to n xi minus yi, where xi is a component of A and yi is component of B. Okay, so we take the difference. Basically, this is giving us wi. We have seen this subtraction. So we take 1 minus 4, we take the absolute value, that is, so we'll have minus 3, right? So if you take the absolute value, you'll get 3 here, and then here you'll get minus 3, but if you take the absolute value, you get 3 here. Sorry, so it should be 6, it should not be 9. I made a mistake here. So here also it should be 6, and here also it should be 6. Sorry, my mistake. I might have done some multiplication. So basically, let me just cross this. So this is 6. Okay, let me cross this 6. This is 6. So The L1 norm of vector AB is 6, and the Manhattan distance between point A and point B is 6. So both of them are same. And the formula is pretty straightforward. Here we are taking the absolute value, and there we are taking a square and then taking a square root of the whole thing in Euclidean distance. Uh, we can also calculate the L1 norm of this vector A, right? Which is originating from origin, basically from 0, 0 coordinate. So L1 norm of this vector A is Manhattan distance between origin and A, which is equals to absolute value of 1 plus absolute value of 2, that is 3. Right? The coordinate for A is 1, 2. So if you take the absolute value of each of the components, you get the Manhattan distance. Let me plot this vector A 0 and it's at 1, 2, right? 1, 2. This is our point. So we are taking one unit, uh, this is 1 unit distance in S component direction, right? And in Y component direction, we are having 2 unit distance. So this is like M1, this is M2, this is 1, this is 2, right? So 1 plus 2 is 3. So that's how we get the Manhattan distance. So if you have any queries, please comment. And if you like and subscribe, that would be great. See you next time. Bye.